All right, well, hi everybody. Thanks for coming to our talk or for tuning in to our talk. So today we're going to be talking about animations, but first we'll do some intros. I'm Guido, and I'm a co-founder of Rive and also the first designer at Rive. So I head up our design team. I'm going to be talking to you a bit about animation and what we do at Rive. And then Umbi is going to go into the meat of the presentation, which is more engineering focused for our audience here at Android Summit. So Umbi, do you want to introduce yourself?
Sure. Hi, guys. I'm a software engineer at Rive. I've been with the team for 3.5 years. I'm excited to show you a bunch of stuff that we have ready for this talk.
Cool. Thanks, Umbi. So today we're going to talk about creating real-time animations for multiple platforms using Rive. Since we're at Android Summit, we're specifically going to be talking about Google's platforms. And we'll start out with an overview of how to create the animations with Rive, and then we'll jump into some examples. So first up, why even go through the effort of creating an animated experience? So I think we're all probably familiar with the benefits of adding animation to like a button or a page transition. The UX benefits there are widely understood and accepted. In fact, both Google and Apple have done a great job providing built-in design systems for most of these types of interactions, which we believe, by the way, that you should absolutely adhere to so that your product fits in its appropriate ecosystem. But we think you can go further than just the built-in stuff. We think there's a next level of interactive motion design that is possible with the right tools. So I'll play this example login screen, and if you've been to our talks before, you might be familiar with this interaction. It's a login screen that has a bear character that's kind of following along as you're typing your email address. You can see that as a cursor moves, the bear, affectionately we call him Teddy, he follows your cursor. He'll cover his eyes if you go to the password field. If you try to log in and your password's wrong, he gets this upset animation. If you type the correct password, he's happy. So this type of interaction allows your app to stand out, first of all, in ever more crowded app stores. It allows it to be more memorable, and it makes a more engaging experience for your customers. It makes them feel good about having accomplished something as simple or basic as a login screen. So why don't we see this animation more, like this level of motion graphics? And the answer is that it's not an easy process to do this. You typically have to design in one app, then maybe animate in another app or prototype it. Then you have to convert it to code, or you got to use a plugin that exports from some tool that isn't really made for real-time interactivity. And then if you want to iterate on any of that, you typically have to start the process all over again. And what makes this even harder is when you have to deploy these animations across multiple properties, like maybe your website, your Android app, your iOS app, some custom hardware component, your social media, the list goes on. So we created Rive to help designers build assets for real-time products, not for linear videos, not for movies or TV or anything like that. The animations you create in Rive run directly in your final product, and they're built to be interactive. You don't need to recreate these in code. So how it works is that there's two parts. One part is the editor, which is online and collaborative, and this is where designers work and create assets. And the other part is our runtimes. The runtimes allow you to deploy your animation to all your products, properties, various customer touch points. And these are open source libraries that allow you to load and control your animations in Android, iOS, Flutter, Web, and C++. We're planning on adding more runtimes in the future, and our goal is to make it so that you can deploy Rive animations anywhere. In fact, why don't we launch the poll right now? We have a question for all the audience members on which runtime are you most interested in? And we'd love to know what you think. So let's move on to the more creative part of this demo or of this talk. We are going to show you how to implement this funky loader today. So let me play that one more time. So we're gonna show you how this is set up in Rive, and then how to actually implement it in Google's mobile platforms. That's Android, Flutter, and the web. But oh, thanks, Umbi, if you can keep playing that, yeah. By the way, this is inspired from one of Umbi's favorite books. And the answer, if you're wondering, is yes. Today, we are going to make an Android dream of electric sheep. If you are not familiar with that reference, the movie Blade Runner is based off a book called Do Androids Dream of Electric Sheep. So let's jump into Rive and actually show you how this file is set up. I've got this tab open here.
Sharing the results quickly, then I'll stop it.
Oh, I see. That's why that's popping up. I was trying to get rid of it. Cool. So it looks like a majority of folks here are interested in Android, which is great, and Flutter. So we'll be showing both of those. Do I need to hit share results actually? Is everyone seeing this, or am I the only one seeing it?
Everyone should have seen it, but now I hit it.
Okay, cool. All right, so this is Rive 2, actually. This is the new version of our tool. And we're in a shared team here called Examples, which Umbi has access to as well. So your designers and engineers have access to the same files. I'm going to go into this folder called Android Summit, and I'm going to open our file here. You can see that Umbi's in here with us, looking over the file. So this is useful for engineers can look at how files are set up and rigged. And the things that we want to call out here that that as an engineer, you particularly might care about knowing is we have a hierarchy on the left, and this sort of represents everything that's on the stage here, all the components that make up this project. And you might be interested in the hierarchy because all the items here, all these nodes, all the components, as long as they have a custom name, you can target them in the runtimes later, and you can manipulate them with code. All of this can be manipulated. The other thing you might want to pay attention to, which isn't so important for our demo today, but the artboard name here. If you have a file that has multiple artboards, so in this case, we only have one, so the runtimes will default to the default one, but it's worth knowing that you can target different artboards if you have a file that's like full of multiple icons or something like that. And just to quickly show what's sort of special about the editor here is that we were talking about this being built for runtime and for real-time animation. You'll notice that I can interact with stuff and make it move all in real time. There's no pre-rendering happening. This is all rendering at 60 frames per second in real time. And I can manipulate here. Let's go a little closer here and show you how stuff we have this little leg of the sheep that like bends and moves around. I'm going to undo that so that we don't screw up our animation. And let's switch it over to animate mode. And in animate mode, I'm just going to hit the F shortcut so that we can center our view, fit everything. And I'm going to hide the bones so that the view is a little cleaner. And what's interesting here from an engineer standpoint are the various animations. So this is unique to Rive, the ability to have multiple timelines attached to a single artboard. And this is something that you typically don't see in animation tools because it's something that you don't really need for linear animation, but you do really need it for interactive animation. And we'll get to why that is, but just to demonstrate some of these here, we have a start animation, and you'll want to pay attention to these names because we're going to be referencing them in the code soon. So we have this start animation, which is what we use to make our loader appear. So that's just a really simple, basic linear transition that just plays when the loader first appears. Then there's this end animation, which when your loading has completed, we're going to trigger that animation and our electric sheep go away. And this fun little real sheep hops in and like kind of says, hello, what's up? And then the part that is interesting as far as mixing goes is when we're in the indeterminate state of our loader. So if the loader is still processing, like it's loading something, whether it's a video or a section of your app is the way we have it set up for the Android demo we're going to show you, we go into this sort of indeterminate state where the sheep just start moving up and down. And that keeps looping, and it keeps waiting until we tell it to mix to the end animation. And on top of it, we have this sheep vibration, which we use to make it just a little more interesting. I'm going to zoom in here so you can see that a little better. And you can see that all the electric sheep heads are kind of wobbling, and we can blend those two together so that the vibration and the movement will happen at the same time. And you'll notice that the timelines here are actually a different length, and that doesn't matter. That's still going to blend together because this is made for interactivity. The last part I want to show you is in the end animation. You'll notice that we have a bunch of blank keys at the start. We don't actually have a key, and that's because when these heads move down, they can move down from any position. They can move down from, you know, if we interrupt this animation while it's here, for example, one head is already down or two heads are already down, one is up, we can trigger this end animation and it'll make them all move down regardless of where they are. So again, this is built for interactive content. It's not built for linear where you need to wait for certain loops to finish or for it to be on the right frame to move ahead. So let's go see how this actually works in code. The last thing I want to show you is that you can download here. You have this share button and hit download. It's going to download the file. Umbi has access to it too, so he can do the same thing. And we'll switch back to the slides and walk you through how this works. Over to you, Umbi.
Thanks, Guido.
Oh, no, there you go.
Yeah. So I'm going to move on and make us take a look at our runtimes and some code. The editor you just saw in the demo was all built in Flutter, by the way, and that allowed us to spawn our Flutter runtime directly from that code base. But all of our other runtimes are using a single C++ layer, and this means that we can ensure that Rive files will be loaded the same everywhere. And there are, of course, less bugs to fix since there's less code to maintain. The way we've approached this is that we can add a lightweight layer on top of that to ensure that the API stays lean and is consistent throughout. Lastly, our C++, using C++ allows us to squeeze more performance across the board. What about the API? Well, on the Android side, we're using Kotlin. So we can be modern, and we're trying to keep the API at low level. This way, developers control time and the render loop directly. They can control the full experience from start to finish. And as Guido has shown you, you can manipulate nodes, you can manipulate single elements, you can manipulate keys. So this allows you to do all of that. And drawing is done using the platform APIs. That is the Skia canvas and its primitives. Android has been using Skia for years, I think since the first version of the API. So we can be consistent. Well, again, since we built the editor in Flutter, which is using Skia as well, there will be no surprises across the board. Our runtime is open source on GitHub, so we're looking for the community's feedback. Go take a look and tell us what you think. Let's look at today's example. So let's move on. Okay. But before looking at the code, I want to take a look at the API, how we approach this. There's an example in the repo, as I've said. So what does the example look like? First of all, we're looking at a custom Android view because we want to leverage its lifecycle overrides. So resources are initialized within the onAttached to window. Drawing instead is performed within the onDraw call that has a canvas parameter passed in, and that is the Skia canvas and its primitives. The Android views can be flagged as dirty calling invalidate, which is a function also provided by the Android SDK. And this will tell the system that the view needs to be repainted. And by telling the system this, we can loop the drawing cycle and properly animate on vsync. You probably are already familiar with views, so let's move on and take a look at the Rive classes. First of all, we have the file. File is a lean wrapper for importing Rive files throughout our C++ endpoint. The file that Guido has shown you that's been downloaded is a binary file, and this format has allowed us to contain all the data about the hierarchy and animations, but also to be as compact and as efficient as possible. And then we have the artboard and the animation. These two components are containers. The artboard is the container for the hierarchy and for the animations. but the animation is the container for the set of keys that you've built or that your animator has built for that particular animation. Linear animation instance is an instance of the animation that allows you to manage its playback. Control it however you want at runtime, change its time, its looping logic, override the way the animation advances, speed it up, play it backwards, do whatever you want. And lastly, I want to mention the renderer here. This is a lightweight abstraction that our team worked really hard to get together. And this lets the framework draw. Right now, this is tied to the Android canvas in our example, but if you wanted to render anywhere else, you can build your own, as long as the operations are the same, but the abstraction helps you in building these operations. So these hooks open up a series of possibilities for the developers. You can grab references in the node, you can grab references to animations, and you can modify what you want. So let's move ahead and look at some code. Oh, whoa, that went.
I think you jumped ahead of it.
Than we wanted. Sorry, guys. Some zoom. All right, here we go. I wanted to show you how to set up a render loop in a custom Android view. First of all, let's override the onDraw function. This is a method that has a canvas parameter object, and the view can draw its contents on it. This is called every frame, and every time that the view needs to render, so when it is flagged as dirty. And this makes it ideal for us in using it in our animation context. We have an initial calculation here for measuring how much time has passed since our last frame, and there's a parameter that stores the last delta. By knowing this, we can move the animation forward consistently. Then we want to look at how to set up the renderer properly. The canvas that it should draw on is passed in here and is reset to the proper reference. This way, we make sure that the renderer will submit the commands to the canvas currently associated with its view. We know that Android could recycle previous canvases, and this reference needs to be up to date. Then we tell the renderer to align. We know that the artboard has its own width and height. We know that the view that you've created has its own width and height, and we want to fit the contents properly. By passing those dimensions to the renderer, the object can be set up properly and the canvas accordingly, with the right transfer space matching the fit and the alignment that you provide. So next slide. Let's get to the juicy part. This is the core of the animation API. If we have an animation that's playing, we advance it by the time delta we calculated initially. And once the animations have been advanced and the changes have been applied, we advance the artboard as well. This method call is important because it'll effectively update all the components in the artboard. When you advance an animation, you get the set of keys that are applied at that point of time in the animation. By advancing the artboard, you update the components so that they are properly updated to the right values. If we didn't validate the view here, which we're doing as a last command, we wouldn't have an animation. So onDraw wouldn't be called again, and it'll be just a static image. So we call invalidate, we move forward, and lastly, we tell the artboard to draw with the renderer on the canvas. This is where the magic happens, and I want to mention we're bundling these calls within a save and a restore, so that we make sure that the canvas and its transform spaces are kept consistent throughout. So this is a render loop in Android, and you can see that in 25 lines of code, you can make your Android dream of magical things. Bear in mind that this is an example of how you want to set up a render. You can set up a render loop in Android. And we're going to take a look at an example in Flutter and JavaScript as well. But by understanding the basics here, you're going to be familiar with the other code that we're going to see in the next few slides. So this is the magic of an Android app dreaming of our electric sheep. And so there you go. We make the app load we make the app load a list. So this is our indeterminate loader. And here we go. Ooh, sorry. Let's see it again. You click a button. You can see that you can interact with the animation. You can stop it whenever you want. The switch shows you that if the loading is finished, you can toggle the finish animation as well. So let's move on. Okay. The other crucial part to our Android runtime exploration has been to make sure that the size of the runtime is minimal. The impact is minimal. So let's say you decided to try this out in your app. What would your APKs, how would your APKs be impacted? Well, Android has always been very, very sensitive about this stuff. And here's a breakdown of the current version of the AAR. Since Android runs on a multitude of devices, the library packs together all the required ABIs, and those are, you might know, the application binary interfaces. When packing all of them, we're getting the output at around 1.5 megabytes. But in our breakdown here, you can also evaluate the impact of a single ABI, and the results are even better. If you want to make sure that space is used as efficiently as possible, you can use your Gradle to filter out the ABIs you don't need, and especially x86 and x84 and x64 are generally used when debugging in the emulator. And for maximum efficiency, another possibility is to use APK split, generate multiple APKs, one for each architecture. Bear in mind that this is bound to increase because we're going to update the runtime with future versions to add more features to our library. But we want to keep it as minimal as possible, so we're going to keep an eye out for this. Lastly, since Android requires developers to deal with multiple architectures, but also with multiple SDK versions, I want to mention that we're currently targeting version 23 as our minimum SDK version. All right, we've seen Android, but what about Flutter? I've seen a few people answer that they want to see Flutter as a possibility in the poll, and it's definitely on the table for us. Flutter, for those not familiar, is a Google framework for shipping Android and iOS applications from a single code base using a language called Dart. At Rive, we're big fans of Flutter. We've been for a while, and we've built our editor with it. Flutter is a reactive framework. It builds UIs with widgets, and widgets are simple components that can be declared and added in code via a build method. This is very similar, for those of you who know React, to the interactions with the render function over there. And since we've built the Rive editor in Flutter, our Flutter runtime spawns directly from that code base here. It's not using the C++ layer that I've mentioned at the beginning of the Android example. In fact, by using a custom Rive widget, our Flutter runtime is directly controlling the rendering process, differently from what we just saw on Android. So let's move on to see a couple of snippets on how to build a custom stateful widget for drawing. So first of all, we want to set up our state. And through the init state function, we get this called once when the widget is added on the screen. And we use it as an entry point to fetch all the resources, for example, like you see here, the binary file, the binary bytes from the file system. Then, like we did on Android, we're going to build a Rive file object. We import the binary data into it so that the Rive hierarchy and the animations are built in memory. And then we grab a reference to the artboard. This is really important because our Rive widget will depend on this artboard. But differently from what we did on Android, we'll add a controller for our animations to the artboard called simple animation. But same as we did on Android, we're passing the name of the animation. And then Guido's shown you in the editor, the name of the animation needs to match with the one that you have set up or that your animator has set up in the editor. So be careful about that. All right, we've set up the state and we've loaded our bytes. So what does the build method look like? It's really simple. You see here that the Rive widget is added at the center of the screen, and it'll take the artboard reference that we've initiated in the init state. Rive contains all the logic for the render loop. So instead of setting that up like we did on Android, that widget takes care of it for you. This is obviously an example for how to set up a render loop. So if you want to go take a look, take a peek at the code, it's open source, and give us feedback. So let's see this in action. All right, we're running a simulator. We see that the animation is the same, the Rive file is the same, and here the loop is the same. And you see that Flutter, Skia, and Android, they all provide the same result. So we got what we wanted in Flutter, we got what we wanted on Android, but at Rive, we're also big fans of the web. The web is a great platform, and people have been shipping animations, shipping applications on the web for a long time. And we believe that web pages shouldn't be second-class citizens. They deserve to have great interactions and animations as well. This is why we have a runtime for the web too. And on the web, we're using the same C++ base layer that we're using on Android with WASM, WebAssembly, to tie everything together. We're trying to be as lightweight and as feature-rich as possible in our current setup. On the web, we've tried to relax the requirements for Skia, and we support multiple rendering systems. Currently, in fact, I'm going to show you how to use this with Context2D. So let's take a look at this. Context2D here. So we have a setup. We grab a reference to the Rive canvas, and the canvas renderer here is initiated with the Context2D context. So I'm going to skip a few steps here, but still the same. We're going to grab the binary bytes. We're going to initiate the Rive file with it. We grab a reference to the artboard, and we load the file. And we initiate the animations, same name, and we wrap it with the linear animation instance. So the API is consistent here too. How do we set up a render loop in the browser? Here's an example of how to do that. In JavaScript, we use the request animation frame that the browser provides so that we can loop this draw call. And this code, in fact, will look very familiar to what you just saw on Android. By using Context2D here instead of Skia, we are using a slightly different API, but the abstraction to the render allows us to have the exact same result nonetheless. So let's see it. Here we go. We've got a browser. We've got the same animation, the same file, and we can loop the same way. So the loader works the same way across all platforms. So there you have it. As I said on Android, we are very careful about size, and not only on the Android side. We want to be feature rich and lightweight. And what we've obtained here is that by WebAssembling the code, we have 37 kilobytes of WASM code here. And the JavaScript side is 14 kilobytes. If you gzip the animation, a sample animation file like the one we've shown earlier, this is going to be less than 10 kilobytes. So if you want to include an animation on your web page, this will sit in the low 100 kilobytes. Again, like on Android, the size here will increase over time as we add more features to the runtimes, but we're going to keep an eye out and we're going to try to keep it as minimal as possible. So there you go. These are our runtimes. They work across the various platforms, the various Google platforms. And we're going to give you the opportunities to click in the links by providing you with the slides later. And you're going to see the Android runtime. We have a repo containing the example that I show in detail with the whole app and the whole flow with the indeterminate loader. We have a Flutter runtime, we have a web runtime, everything is open source, and we're looking for your feedback. So don't hesitate to open up PRs, take a look at the code, give us feedback on how to, if you think that the render loop can be implemented differently, if you have improvements across the board, we're obviously open to feedback, and we're actually encouraging it. So don't be shy.
Cool. Thanks, Umbi.
This is a wrap. Yeah. Thanks, Guido.
Yeah. So yeah, you've got our contact information here. You can reach out to us on Twitter, email us at hello@riveapp, or follow the official Twitter account for Rive. What we demonstrated today is a new version of Rive. It's currently in private beta. But if you message us and let us know that you participated at Android Summit, we'll bump you into the private beta and give you priority access to it. And like Umbi said, we'd love to get your feedback. All the runtimes are open source. Hopefully you've seen that our goal is to make it so that you can deploy Rive animations anywhere. We're planning on releasing more runtimes, and we're looking to our private beta group to let us know what the next runtimes should be. Also, like Umbi mentioned, you can take our current runtimes and fork them and make new ones based out of them. We encourage that. Send us PRs and yeah, let us know what we're doing well and what we're not doing well. That's it for our talk. We'd love to hear from you and see if there's any questions. Was there anything in Slack? I heard some notifications coming in, but looks like not.
No, I haven't seen anything in Slack. I'm posting the Slack channel in the Zoom chat in case anybody hasn't joined.
Okay, cool. How do I bring up the chat here, actually? I think there's a way to, oh, here we go. Come on, don't be shy. Someone ask something.
I've also unmuted all participants, so if you feel more comfortable just asking your questions live, feel free to do that as well.
One thing we mentioned, but we didn't demonstrate, is the iOS runtime. That's something new that we also released earlier this week. By the way, both Android and iOS were just released this week. So that was, you're getting this stuff hot off the press. Yeah, similarly to what we showed you with Android, we have a native iOS runtime as well, that if there are any iOS developers out there, we'd love to see you check that out too.
Hey, quick question.
Sure.
You guys utilize a lot of C++, from what I understand. Was there any thoughts of utilizing like a language like Rust as well, which has like better memory management support?
We've definitely talked a lot about Rust internally, and we've had a lot of feedback about it too. We've heard from the Twitter community about it. I'm personally probably not the right person to answer that. I don't know, Umbi from the engineering team, if you can share any thoughts. My suspicion is that we chose C++ just because it is so prevalent and such a standard for such a long time. But yeah, Umbi, from the tech perspective, feel free to add what you think.
Sure. Yeah. I mean, Rust has been really cool, and our CTO has looked into it very carefully. And but C++ provides hooks into the various platforms that I believe Rust still doesn't. So on iOS, there's a C++ binding that's easy to be put together. On Android, we have the NDK, so we could rely on that. I don't think we've investigated the opportunity to do that in Rust, but if there's ideas there, we're obviously open to hearing them. So
we also have a bunch of customers that actually have custom hardware. So it's just C++ in general tends to just be more accessible across all different types of hardware. Looks like we got a question in the chat. Sure. Tyson's got a question. He'd like to chat about using Rive and Flutter for an app. Yeah, feel free to reach out. We'd love to chat with you. And if you have any specific questions, I think everyone's unmuted, so feel free to ask. We've got time to answer questions. Keeping an eye out on Slack here too.
Hi, I'm Tyson.
Okay.
Hi, thank you. This is really awesome. And again, so I actually have aphasia, um, and it's better now. But I want to go other ones too, because I have something now, but again, I want to do something that's even better, and then I want to have other ones to have that. And so, also, aphasia sorry.
Hi, I'm his daughter. Basically what he's saying is that he has aphasia and he'd like to somehow make a aphasia app with these, with Rive and Flutter to help other people with aphasia.
Yeah, thank you.
Yeah, that sounds great. We'd love to help, and I think there's definitely been a lot of education apps that we've seen built with Rive because there can be, kind of this new, more kind of a deeper level of motion graphics, and for any kind of assistance or learning based thing, we've seen a lot of success with animation. That definitely helps a lot. So I think it could be a really good fit, and yeah, we'd love to chat. Feel free to either ping us on Slack or reach out to us on hello@riveapp. Whatever works best. We'd love to chat.
Thank you.
Of course.
Hey, this is Johnny. I have a question for you.
Sure.
Great talk, by the way.
Cool, thanks.
This is, I don't want to start any wars, but I know that, so I saw you guys at Flutter Live in December 2018 in London. It was awesome. And I know that initially Flutter was a lot of focus, and it's great to see the focus on Android and iOS native now. I'm curious your thoughts on sort of the future of mobile app development in terms of where you're coming from.
So I can answer my thoughts, and then maybe if you have different thoughts, you can answer yours. I think we love Flutter, like Umbi mentioned. We built the entire editor that you saw is actually built in Flutter because it allows us to get a native performing desktop, deploy directly to the web. We will soon be able to deploy an iPad app, and it just allows us to have to really have a cohesive story for our multi-platform editor. That said, though, we don't want to pick sides there because we know that, like we were saying before, our customers and ourselves, we used to run a design and development agency in the past, and we know what it's like to build a product, and you can't be religious about the platform you want to support because your customers are everywhere. You might have customers on any kind of different software, hardware, and devices. And so we think that the right approach is to make sure that Rive is multi-platform and that we have these runtimes that allow you to deploy to your engine of choice. I think the choice that we're seeing is awesome. Flutter is super powerful and allows you to do a lot of great stuff. But then there's also, understandably, things that you need native controls for, like if someone's trying to build for the latest and greatest iOS app and they have some custom hardware where Flutter isn't an option. So I think that from our perspective, we are very agnostic to platforms. We think all platforms bring their own merits, and we want to make sure that our runtimes work across all of them. That's my high level thinking on that. I don't know, Umbi, if you have something else you want to add from an engineering standpoint.
Well, that was pretty much it. Just to add on top of that, performance is also a big focus of ours. So having access to multiple platforms means experimenting with different technologies and finding the best fit. So we're open to all of that. We're really excited about what we've seen in the mobile area. There's been a lot of really exciting developments over the past couple of years, and so yeah.
Yeah, I think it's great, right? To have choices is really awesome. There's tons of apps that don't need even the performance or the low level control of Flutter. There's apps that you can really easily build as a web app or React Native, that there's perfectly good reasons to go in that direction to have something quick and fast to get out. But then if you are building more of a, you know, interactive, gamified kind of thing, and you want it to, your engineering team reflects a team that wants to have one code base and not have to be split into a Android and an iOS team, then Flutter absolutely makes sense. It's a no-brainer for a startup trying to get something quickly out and get their product in people's hands, and, you know, iterating in kind of lean startup like mentality. Flutter is just hard to beat there, I think.
Awesome, thank you.
Cool. Hopefully we didn't start any wars. It's the last thing we need in 2020. Is there any platform that we don't support that anybody is really excited about or would need, you know, that you're currently working on, something maybe that you think would be super interesting for us to look at as a potentially next runtime to tackle? Anybody building anything custom hardware or anything like that? We have a few customers that are in the probably don't want to share names, but that are working on some hardware-based stuff, and I think they obviously get a lot of advantage out of being able to deploy animations to their hardware and then their apps and their website without having to you know, build different versions or recode everything. We've also obviously have a soft spot for gaming. Our company actually started as a tool for game development, for building characters, which is why you see, like, you know, skeletal animation and bones and stuff like that as parts of our features. So obviously we have a soft spot for game engines. That's something that is obviously something we're looking at for the future.
Yeah, that's also where C++ comes in handy.
Right, yeah. Oh, we've got a comment in Slack. I'm really excited to use Rive on Android. I've been using it in Flutter and it's really awesome. So, sweet, thank you. And I swear I didn't write that. Yeah, I think Android was probably one of our top most requested features from Rive 1, which is the previous version of Rive.
And also, yeah, I guess Guillermo is using Flare Flutter as a package, and
yeah,
as people are coming in the beta, they're gonna move on to our Rive Flutter package, which is the library that we're using with the new version of the files and the new editor. So
yeah, that's right. That's right. That's worth calling out, that if you've worked with Rive so far, you've been using Rive 1, which is our product from last year. Rive 2 is a complete rebuild. Everything is brand new. The format is new. The runtimes are better. They're smaller. They're leaner. Their performance should be better as well. Our old web runtime actually packaged Skia into it, so the file size was really big. The new WASM runtime, like Umbi showed you, is really tiny. We think that there's just a lot more possibility to what you can do with it. And it's a lot more feasible if you want to have small animated icons to full-blown animated experiences. You can use it for both, whereas previously, you know, loading a multi-meg runtime for a website made no sense if you just wanted to have, you know, an animated icon or your logo animating or something like that. Now, in fact, if you go to beta.rive.app, our site, you'll see that we're using a lot of animations, and the total of all those animations is smaller than a static ping or JPEG would be. I believe the version we're using on our site is gzipped. The runtime is something like 50 kilobytes, and then the animations that you're seeing on the site are anywhere from 3 kilobytes, 7 kilobytes, and I think the mech animation at the very top, in fact, I can just load it here. That one's the biggest one, which is coming in just under 30 kilobytes. So yeah, this animation that you see here, it's kind of got more graphics, more detail, more animation. So this one's closer to 30 kilobytes. But as we scroll down here, all these other animations are like a couple kilobytes. I think this one might be 7, or maybe this one here is the one that's 7 because it's a little more detailed. Others are only, I think this truck animation is only 3 kilobytes. Again, I actually encourage you to go check out the website because you can mess around with the animations and actually, like, you know, make them go into slow-mo. You can interact with them. You can just, yeah, we encourage you to mess around with it, and you'll see that the total file size for all this is less than what a static image would be in most websites. So we're really excited about what you can do, particularly with a web runtime, now that it really is tiny, and it really is feasible to include it in any website.
So it looks like we're good on questions. We'll also have the Slack channel up if anybody has any questions later down the line. But yeah, thank you to our speakers. This was a great presentation.
Awesome, thank you. Thanks for having us. And yeah, we look forward to seeing everyone in some of the other rooms and the other talks.
Thanks so much for setting this up. This was great.